Okay, this time I thought I would do a video on how to apply the roots and have fractions as exponents. So in my previous video I talked a little bit about what this meant here on the outside. So the sixth root of x to the fourth power. So I can rewrite this as saying x to the fourth power to the 1/6 power plus, and then here I have x to the sixth is inside, and I have to the 1/3 power. And so when I do that, I can apply my properties of taking a power to a power. So I have x to the 4/6 plus x to the 6/3. So I have x to the 2/3 plus x squared. And from here, that is as simple as I can get it. Looking at b, we can apply the same type of concept. I have a to the fifth inside the radical, and to take the radical away, that's the square root, so I'm going to take it to the 1/2. Well, then I have that whole quantity, and it's to the third power. So I have to work from the inside out. So first I have a to the 5/2, and I have to take that to the third power. So then I have, I have a to the 15th to the second power, or 15 over 2, because I multiply, taking a power to a power, I just multiply my exponents. So from here, we talked about this towards the end of class today. I know that I have basically taken the square root, and I can simplify this a little bit more because it's an improper fraction. And so what this says is, and you can take it to the side, and it says 15, and I'm going to divide it by 2. And 15 can go into 2 7 times with 1 left over. So what that means is when I'm rewriting this, and I'm not going to rewrite this because it tells me to take it from a radical to a fractional exponent, but if I was going to simplify this all the way and take it back to a radical, I would actually have a to the 7th and take the square root of a. So that's what it would look like in simplified radical form. But this is the actual answer that they're looking for in this case. The next one, C, is I have 4b squared to the third, and I take all of that to the 1/2 power, because all of this is underneath the radical. So I have to do 4 cubed b to the 6th, and then I have to take all of that to the 1/2 power. So 4 cubed is 64, b to the 6th, and then I still take it to the 1/2 power, and 64 to the 1/2 power, and b to the 6 over 2 power is going to end up being 8 b to the third. And that would be your final answer. Moving on along to D, I kind of do the same type of thing. I have 243 x to the 25th, y to the 12th, and then z to the -8th. And all of that's going to be to the 1/5 power. So I'm going to take 243 to the 1/5, x to 25 to the 1/5, y to the 12th to the 1/5, and z to the -8th to the 1/5. And how that looks, I do believe that that is 3. X to the 25 divided by 5 is 5. Y to the 12/5, z to the -8/5. And so the only thing here is, I know I can't have a negative in my exponent, so it becomes 3x to the 5th, y to the 12/5, and that is all over z to the 8/5. And that is your simplest form in radical form. I mean, not in radical form, in exponential form. The next task that we had today in class was to go ahead and rewrite these using radical form. And so A is x to 8/3, and that's going to be x to the 8th power, and I'm going to take the cube root of that. B looks like a to the 3/2 power, and so in this case it's going to be a cubed taken the square root of it. C, 8 to the 5/3 is equal to 8 to the 5th power, and I'm going to take the cube root of it. And then the last one is D, and it is, I'm going to have to put it over 1, 3/4, and so it's 1 over the 4th root of 81 to the 3rd power. So you can kind of think of it in that form. So moving on along, let's look at some of the problems on the back, because they do get a little bit more complicated. I'm going to look at D on the back, and this is going to look something like this. I have a to the 1/3 times a to the 1/6, and I'm going to take all of that to the 4/5 power. Well, I'm multiplying the same base together, but it has different exponents, so I can add the exponents. So, but I have to have common denominators. So my common denominator here is going to be 6. So I have a to the 2/6 times a to the 1/6 to the 4/5. So I'm going to add my denominators, exponents, a to the 3/6, and then I am going to take that to the 4/5. And of course I can simplify a to the 3/6 to a to the 1/2, and I want to go ahead and do that to the 4/5, and then from there it is a to the 4/10, and to simplify there, a to the 2/5 is my final answer. Looking at E, I have m to the 3/4 divided by m to the 1/2, and I'm going to take all of that to the 2/3 power. So here I'm going to subtract my exponents because I'm dividing it. So I have m to the 3/4 minus 2/4, because I'm going to go ahead and make that 2/4, my 1/2. So, but I still have to take that to the 2/3 power. So I have m to the 1/4, and I'm going to take that to the 2/3 power, and I have to multiply power to power. It's going to equal m to the 2/12, which is equal to m to the 1/6 power. And that's your final answer there. Looking at F, it says rewrite in rational exponent form first. So I have h to the 2/6 power times h to the 1/3 power. And so when I get it this way, I can see it's the same base, and I can add my exponents, but I have to have common denominators, times h to the 2/6 power, and that's h to the 4/6 power, which is equal to h to the 2/3 power. So that would be my final answer there. Going down a little bit further, G, it looks like x to the 1/4 times x to the 1/6 divided by x to the 1/3. So how this is going to look is it's going to end up being x to the 1/4 plus 1/6 minus 1/3. So I have to make common denominators, which is going to be 12. So x to the 3/12 plus 2/12 minus 4/12. And so that's going to be 5/12 minus 4/12 is x to the 1/12 would be my final answer. And then moving on along to B, I would have x to the 1/2 over x to the 3rd, and so I have x to the 1/2 minus 3, which is going to be x to the, let's see, negative 5/2, and because it's a negative exponent, it's going to be x to the 5/2 is in the denominator. And then the last one, C, is going to be p to the 5/3 divided by p to the 2/4 times p to the 1/3. And that's going to equal, I'm going to simplify this, p to the 5/3, and then I'm going to say p to the 1/2 times p to the 1/3 is equal to p to the 5/3 over p to the 3/6 times p to the 2/6, p to the 5/3 divided by p to the 5/6. And so when I simplify that, it's p to the 10/6 minus 5/6 is equal to p to the 5/6. And that would be my final answer. So hopefully that'll get you a little bit more acclimated to what we're doing here in class.